Hello, ladies and gentlemen. This will be our second video in a series of 3. This is a video to help you find the area of a triangle if it's isosceles on the coordinate plane, right? So if you notice here, this is just kind of an overview of what happens or what we do to find the area of an isosceles triangle. First, it says use the distance formula to find the length of the base. Now, normally we're going to have all 3 side lengths. So if you notice, 10, 10, 8 radical 3. So these would be the 2 equal legs, right? And then this would be your different base. That's what we're going to use as the base. Now, usually we're going to have to go find the height here. So in this case, they're showing you the height. But typically, here's what we're going to do. We're going to find the midpoint of the base and connect it to the apex, or like the top, right? So in this case, this would be your midpoint of the base, and you connect it to the tippy top, to the apex. This is your height. This is your altitude. Okay. Next, third step says use the distance formula to find the length of that height. So we're going to use the distance formula to find this length. Finally, we're going to substitute the base and the height, label it with units squared. So let's go look at an example of this. So again, on Google Classroom, we have posted extra practice questions. So I wanted to show you this one here. This is question number 3. Now, if you want to see all the calculations, just go open up the answer key. But here we go. We have 25 and 25. So that tells me this is an isosceles triangle. Here's your different side, which, you know what, guys? That makes this the leg. This makes this the other leg. And then this is going to be our base, right? BC is the different side. That's our base. Now, I also want to notice and take a look at the slopes. None of these slopes are opposite reciprocals. So that means this is not a right triangle. So what I have done already, and just try to speed this up. Again, guys, if I'm moving too fast, please use the pause option. So this is going to be an acute isosceles triangle, and I wrote C back, right? Because in order to figure out if it's acute or obtuse, we're going to use the Pythagorean theorem. So just very quickly, briefly, I have already done that on the back here. So 25 is one of the biggest side lengths, right? I typed this in the calculator, right? 10 radical 5 is like 22 point something. So remember, we always have to have the biggest value over here. Now, this is going to be impossible. I know, because I have 25 squared on each side. But by the time I get to the end, I have a c squared value that is too small in comparison to a squared plus b squared. Therefore, going back to the other side, that is why I have written down that this is an acute isosceles triangle. All right, but the majority of this video, I want to concentrate on finding the area. So on the other document, right, what I also just showed you a second ago, this is a checklist of what you should do. So we're going to find the distances, which we've already done of the outsides. Now we're going to find the midpoint of the base and connect it to the top, connect it to the altitude. So I'm going to zoom in here a little bit. I know my work is a little tiny, right? But I'm going to find the midpoint of the base. So ladies and gentlemen, I'm going to be adding negative 13 plus 9, dividing it by 2. Negative 15 plus negative 11, dividing it by 2. So I'm going to show my calculations over here. Again, this is all on the answer key already. So now I'm going to have negative 13 plus 9 over 2, comma, negative 15 plus negative 11 over 2. All right, negative 13 plus 9 is going to give me negative 4, divided by 2 is negative 2. Negative 15 plus negative 11 is negative 26. Divided by 2 is negative 13. So now I'm going to zoom out. Okay, whoops, wrong way. And then I'm going to go to my diagram. Now, my midpoint. We just found the midpoint of the base to be negative 2, comma, negative 13. And I'm going to take out my straight edge and connect that to the top. This is now the height of our isosceles triangle, right? So, you know, one thing I do want to write down here is that base BC, right? This whole length, let me see if you guys can see that. That whole length is 10 radical 5. Okay, that's going to be our base in a minute. Okay, so now our next step after finding the midpoint of the base and connecting it to the top is to find the length of this segment, right? So calling this point M, AM is our height. So I'm going to find the distance between negative 6, 9, which is point A, and negative 2, negative 13, which is point M. So now we're going to go ahead and use our distance formula, which is right here. I'm going to zoom in a little bit. Okay. Now you can see I have height as AM. -6, I'm going to go -6 minus -2. -6 minus -2. Let me continue that down here, right? So that's going to be -6 minus -2. Ooh, that turns to plus. So that's -4 squared, which is 16. Okay, good. Now I'm going to find the delta y, or change in y. So I did -6 minus -2 for the x. Now I'm going to do 9 minus -13. 9 minus -13. Well, wait a minute. That's 22, right? That's going to turn to plus. 22 squared, right? Let's see. Let's take out our calculator. Whoops, I'm losing my space here. Let me type that in my calculator. 22 squared is 484. There we go. Okay, cool. So I should have known that. All right, now finally, 16 plus 484 is going to be radical 500. And now we're going to have to simplify this. So I'm going to split this up into 105. Wow, wait a second. Listen, ladies and gentlemen, we're getting 10 radical 5 as our height. So I just want you to understand something, right? 10 radical 5 is the height of our triangle. This doesn't happen all the time. You won't always get a matching, the height won't always match the base, okay? But in this case, it does. So now, the base is 10 radical 5. My height is 10 radical 5. I'm ready to finish this up. So I'm going to substitute 10 radical 5 as my base, 10 radical 5 as my height. Now, let's go ahead and multiply this all out. Ready? 10 times 10 is 100, times a half is 50. Radical 5 times radical 5 is radical 25, or that's just plain old 5. Okay? So our area ends up being 250 units squared. Okay? Perimeter for the end here should be quite simple, right? For perimeter, we are adding 25 plus 25 plus 10 radical 5. These are the only two like terms, so our perimeter will be 50 plus 10 radical 5 units. Okay, ladies and gentlemen, I hope this helps. This was our situation in which it's an isosceles triangle and we're finding the midpoint to the base.